I forgot to mention this last lesson, but on the left here, that's our sequence. So last lesson we just did like an introduction. This one's going to be adding, subtracting, and timesing. So that shouldn't take too long. And then I guess this is just kind of the rest of it. So that's what we've got to look forward to. That's the advanced content, the advanced sequence. Sorry. Okay, adding and subtracting and multiplying. You'll notice that division is going to take 2 lessons because it's very strange, and we'll get to that. But these are pretty simple. So I've got p of x, that's a polynomial. It's defined by this. So there's a few things we can take from it. Its highest degree, or its degree is 3, because that's its highest power. Its leading term's x cubed, because that's the term that has the highest power. It's monic, because that's a 1. The leading coefficient is 1. The constant term is -5. And that's it. I've got a second polynomial called q. So you notice sometimes when they do questions like this, it'll be in alphabetical order. So p, q, then you might have the next one r, but you know. Anyway, so we use p and q. Q in this case is a quadratic. Its leading term is 3x squared because the degree is 2. Leading coefficient is 3. It's non-monic because that 3 isn't a 1. Its constant term is 7. And yeah, okay, so p of x plus q of x. You might think, okay, how do I add 2 polynomials? Well, exactly how you'd think. What's p of x? Well, p of x is x cubed, and I use brackets, minus 2x minus 5, plus, and then q of x. So q of x is 3x squared minus 5x. That's a terrible x. Plus 7. Okay, so this here is p, and this is q. And I'm just adding them, which literally means I add them. So, okay, there's an x cubed, there's no x cubes over here, so I'm going to have x cubed. I've got an 3x squared, and I've got a 3x squared, and there's a plus. So that's 6x squared, minus 2x, minus 5x, minus 7x, minus 5 plus 7, plus 2. Done. That's it. So if you wanted to be a little bit more proper, you could just chuck in here p of x plus q of x equals, put the equal signs on top of each other. Maybe make that bigger so it doesn't look stupid. Okay. B, subtracting, and look, it's exactly the same, but I use brackets just to be really, really careful, and I'll show you in a sec. So p of x minus q of x is brackets x cubed plus 3x squared minus 2x minus. So generally what I try and do is just get rid of the brackets first. You might think, why did I even use brackets in the first place? Well, just because of the negative situation. So x cubed plus 3x minus 2x minus 5. Okay, so then minus 3x squared plus 5x. So we've got a minus and minus, plus, and then minus 7. So now I can start collecting like terms. So x cubed, okay, I've got a plus 3x squared and a minus 3x squared. So that's 0. So then let's just get rid of them so they can go. Okay, then I've got a minus 2x plus 5x. So that's going to be 3x. And then I've got minus 5 minus 7, which is minus 12. And that's it. So that's how we add and subtract 2 polynomials, exactly how you add or subtract anything else. Multiplying will be pretty much the same, except I just want to show you a little bit of new notation as well. So I've got p of x, and it's that thing, and I want to times it by q of x, which is that thing. So when I times, there's a different thing that we use in advanced, and it's a dot, and it's I think the reason we do it is because you've got so many x's going on. If you have x times x, that kind of looks a little bit weird. So you'll just go x dot x. So this dot, just keep in mind the dot is like in the middle of the words, not like this full stop or a decimal point that's at the bottom. That's really simple that people sometimes do that. You can make more emphasis on it. So some people will go like quite colored in dot. I don't really care as long as it's really obvious that your dot means multiply, not like if I'm doing, because sometimes you'll have things like 4 times 3. You don't want to confuse that with 4.3, right? So, and of course that happens. So just be really careful. Just use a thicker dot if you're not confident with it, but Just, you might have seen me accidentally do this a lot in class, and I know I did, but yeah, anyway. Okay, so then 3x plus 1 times x squared minus 5x. You'll notice I use brackets again, because obviously it would, if I didn't use brackets, that would just imply that these two things are times together, not all of them. And now that I have brackets, I'm going to have to use, and also the fact that I've got 2 terms in here and 3 terms in here, I can't just quickly expand them like I normally would, so I'm going to have to use FOIL. So I'll go that, and that, and that. Okay, so this times this is 3x to the power of 3. This times this is negative 15x squared. This times this is going to be minus 6x. I hope you know what I'm doing here. Okay, and then the 1 times that is x squared. The 1 times that is minus 5x. And the 1 times that is minus 2. Then I can collect like terms. What am I doing? There's no other x cubes, so that can stay. There's an x squared and an x squared. So minus 15 plus 1 is going to be minus 14x squared. Then I've got minus 6x minus 5x. That's minus 11x. And then the minus 2 is the constant term in the end. Okay, there's a couple of things. Oh, that should be a cubed. That's annoying me. So a couple of things I want to take away from this. I know it seems pretty simple, which it is, but there's a couple of things. First thing is try and keep up with what you've done. Like obviously I've drawn these lines on there, and to be honest, you should do that. But if you don't want to do that, and you don't want a messy page or whatever, then it can be risky because you don't know what you've done. So there's a quick check. So you have there's 2 distinct terms in here, and there's 3 distinct terms in there. 2 times 3 is what? It's 6. That means your output should have 6 terms. 1, 2, 3, 4, 5, 6. If you don't have 6 terms, you've missed something. Now, obviously, when you go to collect like terms, you're going to have less than 6 terms, but your initial expansion should have how many terms are in here times how many terms are in there. So that's just a quick little check that you've actually done it all. The second thing is that look at the highest degrees of each polynomial. So the highest degree here is, well, the degree is 1, and the degree here is 2. So if you add those, that should be the degree of the product. So I've got a 1 here, I've got a 2 here, 1 plus 2 is 3. My output or my product has a 3. So that's another check just to make sure that there's just a couple of things that you can quickly verify that your answer kind of makes sense. Because if you didn't have this term in here, you didn't have that, and you know you've got like an x in here and an x squared, and your output is an x squared, then you might think, well, it doesn't really make any sense, and you're right, it doesn't. Anyway, actually, is that a thing? If that was a 2, then actually, if that was a 3, then yeah, that makes sense. Okay, and that's it. So that's how you add, subtract, and times. Division's a little bit strange, so we're going to actually spend 2 lessons on that. But yeah, that's it for that.